Hello everyone, my name is Kunith, and for Dependable AI's Take Home Minor Examination, I will be having an analysis report for ICCV 2019's paper Enhancing Adversarial Example Transferability within Intermediate Level Attack. So basically, we have three different types of adversarial attacks that we have white box, gray box, and black box on the basis of the implementation details and the annotations that we are having. But the black box attacks are pretty hard to produce the results because most of them relies on the zero order approximations and somehow transferability amongst other models becomes difficult or becomes a question itself because different neural architectures have different components, their gradient based behaviors and their feature maps also differ uncontrollably across each other. To facilitate the extent of black box attacks more on the universal ground, the paper authors looked for the source model's intermediate layers where the baseline attack is pushed, and then that combination is implemented to the target model's intermediate layer. So hereby, I have the report that is presented on the screen, where I have explained about the working code, the actual inspiration where I have taken up from the GitHub, the report analysis on the basis of the attacks, the models that they have implemented on, different benchmarks they have tested upon, and specifically, I have picked up Tiny ImageNet 200 because although being a subset of ImageNet, but it constitutes a different inductive bias set and sample-wise distribution. So in this report itself, I have went through with the explanation of the attacks, the insights why the authors have brought upon these components, their specific reasoning, some bit of the datasets overview, and the actual working of the intermediate level attack alongside the algorithm and the variation of the loss functions that they have proposed. Also, in the later stage of the report, I have did a basic analysis, detailed one on the plot side itself, where I have seen the variations of the FGSMs and how they have performed on CFAR, on Tiny ImageNet, and whether the variations in the losses can affect up the CFAR's result for the baseline attack, that is transferable adversarial perturbation. And in the last of the sections, it will these particular graphs will be seen where each and every color line will symbolize a different target model, that is either SNet 18, DenseNet, Google LaneNet, SENet, or maybe an AlexNet and SqueezeNet. So now heading back to the working of the code. So here I have the notebook, which is being named as B19EE046 underscore notebook. So according to the instructions by the course instructors and the teaching assistants, I have mentioned up some of the notes in the headings. So I have already set up the runtime as I'm turning right now to GPU. Now it's being allocated, and I am pretty much working on the collab notebook right now to illustrate in a great manner. So it's opening, and yes, I have agreed upon. So it basically utilizes up Google Drive. So I have to give up the permission of the Google Drive. So here we have the prompt of the Google Drive, the authentication one. So I am agreeing upon that. And with the code snippet that I'm having right now, it will initially fetch up the GitHub repository, the edited and the modified GitHub repository, because I have filled up some configurations and I filled up some visualization notebooks into that repository. And also it will install some of the required libraries such that these scripts can work upon pretty much easily. So after the installations have happened up, we will go to the working directory, which is the intermediate level attack underscore DAI. Then for the demonstration of the working code, I will be running a particular snippet at the fourth section, which is reproducing on the pre-existing CFAR. So for simplicity, I will be running on the Google Lanenet as of right now because I have multiple sections, but Google Lanenet is far more the simpler one to deal with. So in this, I'll be playing with this particular code snippet. So what's the meaning of this code snippet till the time it's running? It's actually running an all-in-one CFR10 script with the source model mentioned as Google Lanet and with the transfer models mentioned as ResNet, StenseNet, GoogleNet, and SENet 18, which I've picked upon with the papers that author have published. Then the predictions will be saved in test.csv, and as test.csv will be produced, I will be showing that how it will initially look. And the authors have also provided up the setting to configure attack. Which type of attack do I have to choose? Either IFGSM, momentum IFGSM, FGSM, Kalini Wagner, or transferable adversarial perturbation. So, since transferable adversarial perturbation takes lesser time than the others, so I am running it for the code demonstration. As we can see, for the first iteration, it's taking around 40 seconds. So, for 50 number of batches, it will just take around 25 minutes. So, in the meanwhile, I will pause in between. And I have set up the batch size of 32. So this essentially will be running an all-in-one CFR10 file where I will be having some benchmarks covered in the script. Also, this particular command line will be helpful to visualize these particular graphs. Alongside that, these particular graphs are pre-processed with with pandas and matplotlib. So I think the test.csv is being formed, if I'm not wrong. It's still yet forming. I think it will appear in a bit while. So meanwhile, I can show how the particular visualization notebook will appear. So this is particularly the notebook that's appeared. I have set up particularly the file from which I have to extract up the predictions. Then it's the particular function that's written upon that will fetch up some of the numerical values, and on the basis of that, it will make up this particular graph. And these are the particular informations that it can possibly reveal. And with the earlier experimentation that authors have did, so it was the particular layover that how it initially have appeared. So one column is for source model, one column is for target model, one column is for full method, which is either IFGSM or FGSM or Kalini pattern or something. And original accuracy is like the original accuracy of the classifier without any changes in the loss. But as soon as I change up the loss, I switch it to either ILA projection loss or ILA flexible loss. The accuracy did pretty much affected, like from 75% to maybe 43% or 69% to maybe 0%. So these readings will be automatically stored up in the CSV, and after they have been stored upon, those will initially be made upon with the layer index. So that's the overall explanation of the code working, and I will pause it a bit as of now to just see the prediction. Yes. So after 25 minutes, it's the batch size that has been covered. Uh, this is particularly the information of the layers that is being covered with the source model. In this case, it's Google Lanenet. The batch size is indeed 49, and as we can see, it's basically the graphs that have been made. So in the Google Net, these were particularly the layers that have been targeted, marked as layer index, and this is the accuracy after attack. So to have a look upon the CSV, test CSV, so I can open it, and here it's pretty much loading. And here, as we can see, that we have the source model file, which is GoogleNet. The target model is ResNet, and it's basically the model file is being loaded here. So if I have to scroll it, uh, let me just scroll it a little bit. Yes. So this is indeed covering up the CSV. Yes. So here the batch size, like it's the first batch that is targeting, the layer that is targeting. It's like ranging from zero to one, two, three, whatsoever. The layer name is pre-layers A3, B3, depending upon the type of the source model that we are taking upon. The full method here is transferable adversarial perturbations, and it's having some combinations of ILA. It's either false or true or false or something. And then we are having fool rate and accuracy after attack. So fool rate across the batches can vary, and across the combinations of the layers and combinations of the target model it can vary. But accuracy is pretty much decreased up in each and every case. So if we will scroll down more and more, so we can figure out that yes, it's been decreased up. And in some of the cases, the fool rate's even reaching 200% as well. So in order to run the experimentations and produce graph more, I was having this particular command line as well, which is exclamation rm test or CSV. Since the visualization notebook heavily emphasized on this particular name, so it was important while making up the graphs to remove this CSV alongside. So as I implement it, as it's running, and as it runs, so if I will refresh it once again, so the test.csv file is being erased. So that's the implementation from the notebook and how it's working. And even if you have to check without projection, without using the projection loss, just using only the flexible loss, here's the command line and here's some of the instructions that will be pretty much required to be edited. So that's pretty much the code implementation. Thank you.